RHS Pre-Calculus presents
Bum 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 bum, ba-da-dum bum bum bum.
Back to the Future, Linear and Angular Velocity.
Wait a minute. Doc, are you telling me that you built a time machine out of DeLorean?
The way I see it, if you're going to build a time machine into a car, why not do it with some style? Besides, the stainless steel construction made the flux dispersion.
Oh, Doc, this is heavy.
Actually, Marty, it's quite light. As you know, we need to reach a top speed of 88 miles per hour in order to activate the flux capacitor and travel through time. I've tuned the engine on this sucker to provide a top speed of 9,424.5 radians per minute.
But Doc, radians per minute isn't even close to miles per hour. How are you going to know this is going to work?
There's no guarantee, Marty, and that's why we're going to do the calculation now. We're going to set up a series of conversion factors to change this angular speed, 9,424.5 radians per minute, to a linear speed in miles per hour. Then we can check if it's greater than 88 miles per hour. We already know that a full rotation is 2 pi radians from the definition of a radian. We can write that into our statement right off the bat. Next, we have to convert those rotations to an actual distance.
Wait, Doc, why are you multiplying by something? Won't that mess up our initial value?
Marty, what you aren't seeing here is that those values are actually equal. 2 pi radians is the exact same as one rotation, so we're essentially multiplying by 1 over 1. It's only changing the units, not the initial value at all. The current wheels I have on this bad boy have a diameter of 1 foot. To find the circumference of the wheel, we'll multiply the diameter by pi. Logically, every time the wheel makes a full rotation, it will travel the distance of one circumference. Now we have feet per minute. We're nearly there. The last thing we need to do is convert to miles per hour. There are 5,280 feet in a mile and 60 minutes in an hour. We'll place these two equivalent expressions into the equation. Now we can cross-cancel most of the intermediary units. Now we just have to multiply and divide it out. Looks like our top speed is about 54 miles per hour.
But Doc, that's not enough. How are we going to activate the flux capacitor?
Oh, I overlooked this inconvenience. Unfortunately, there's no way to change the radians per minute of the engine. That's already been topped out.
What if we change the wheel size?
Marty, you're brilliant. If wheels with a larger diameter are used, we'll end up with a faster linear speed without even having to touch the angular speed. I think I have some wheels with a diameter of 2 somewhere around here. Ah yes, by increasing the diameter to 2 feet, we increase the circumference to 2 pi feet. Now we have twice the distance per rotation. Now let's insert these back into the equation instead and see if they'll work. In the conversion between rotations and feet, let's insert the new distance covered by one rotation, which is now 2 pi feet. We can crunch the numbers again and perfect! 106 miles per hour is exactly what we need. Marty, do you know what this means?
I just applied linear and angular velocity to the real world?
Yes, but more importantly, time travel is now possible.
Alright, let's get rolling and change those wheels.